Section 11.4, we're talking about limits of Taylor series right now. And example 1 says, evaluate the limit as x goes to 0 of x squared plus 2 the cosine of x minus 2 over 3x to the fourth. Okay, so if we look at this, we're going to, that's a minus sign, we're going to use our Maclaurin series for cosine of x. Remember, that's the even ones. And so we're going to put it in, so it's going to be the limit as x approaches 0 of x squared plus 2 times, now I'm going to rewrite those factorials. That would be x squared over 2, x to the fourth over 24, x to the sixth over 720, minus 2, all over 3x to the fourth. Okay, the 2, to simplify this nonsense, let's see, what can I do with this? Put the 2 through, and I'd get x squared plus 2 minus x squared, and I'm dropping the parentheses, even though they didn't in the book, plus x to the fourth over 12, x to the sixth over 360. Oh, I see. We've got to put it in here because of the dots. Minus 2. All over 3x to the fourth. Okay, so if we're looking at this, the x squares are going to cancel. The 2's are going to cancel. And I'm going to be left with x to the fourth over 12 minus x to the sixth over 360 plus over 3x to the fourth, which would then reduce to the limit as x approaches 0 of, okay, I'm going to put the x to the fourth term by term into each one of those. The x to the fourth cancels. I have 1/12 on top and 3 on the bottom. That's going to be 1 over 36. Here, the x to the fourth cancels the x to the sixth, and I have an x squared. And then that 360 with the 3 underneath there, multiply it, makes it 1080. Plus and as x goes to 0, this piece is going to 0, and so the answer is 1 over 36. Let's try example 2. Alright, so for this one, we're going to use a really old technique. We did it a long time ago back in limits. We're going to change x into 1 over t, which would then make x going to infinity, infinity, become t going to 0 from the right-hand side. So this would turn into the limit as t goes to 0 from the right-hand side of, now if I flip all this around like I'm supposed to, it's going to become 6 sine of t over, t to the fifth. And then minus, this is going to be 6 over t to the fourth, and this is 1 over t squared. Getting a common denominator, we get 6 sine of t minus 6t plus t cubed all over t to the fifth. Now if we look at this, that's going to be 0 over 0, that indeterminate form, so we can now use the L'Hopital on this. Well, I would have used L'Hopital, but that's not what they're demonstrating here. They want us to change the sine of t to its sequence. And so I'm going to have, let's see, the limit as t goes to 0 from the right side. I'm going to put the 6 out the outside. Sine turns into t minus t cubed over 3 factorial, that's 6, plus t to the fifth over 5 factorial is 120. minus t to the 7th over 7 factorial is 5040, plus dot dot dot, minus 6t plus t cubed, and let's see, oh, don't need that. Not that one. All of that is over t to the 5th. Okay, so let's clean that up. The limit as t goes to 0 from the right-hand side. The 6t that I would get when I distribute right here is going to cancel with this one. And the t cubed is going to cancel with that one. And so I'm going to be left with multiplying by a 6 into the t to the 5th problem is going to give me t to the 5th over 20 minus t to the 7th over 6 goes into 5040, 840 times, plus dot dot dot, all over t to the 5th. And then we reduce that. And the t's are going to cancel on that first one, so 1 over 20. And here I'm going to get t squared over 840 plus dot dot dot. So all the things in the dot 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 are going to have t's in them. So they're all going to go to 0. And I'm going to end up with 1 over 20. Example 3. It says, differentiate the Maclaurin series for sine of x to verify that the derivative of the sine is the cosine. So we're going to prove one of the things that we've been using since the beginning of Calc 1. So we're taking the sine of x, which we know the Maclaurin series looks like this, minus x to the 7th over 7 factorial, plus dot dot dot. We know it converges from negative infinity to infinity. And so we can do term by term differentiation. So the derivative of the dx of the sine of x, that's going to be 1 minus 3x squared over 3 factorial plus 5x to the 4th over 5 factorial, 7x to the 6th over 7 factorial, dot dot dot. So that turns into 1 minus x squared over 2 factorial plus x to the 4th over 4, oh yeah, look at that, minus x to the 6th over 6 factorial plus dot dot dot, which actually is the cosine of x's Maclaurin series, and so we have just proven it. We won't be doing example 4 because we don't have to work with differential equations, so my next pencast will start with example 5.